Today you will be evaluating and simplifying functions. Some things to remember. Remember, a function is a relation in which each element of the domain corresponds to exactly one element of the range. So what you may remember from Algebra 1 and Algebra 2, so you see how we have this relation over here. -3 only corresponds to 1. -2 corresponds only to 2. -1 only corresponds to 0. And 0 only corresponds to 2. Because each individual input value only corresponds to one output value, we say that relation is a function. Okay, and sometimes we can look at it as a set of ordered pairs as well. Another example of a function is something of this nature. Remember, if the largest exponent is squared, it is a parabola or a U-shaped figure. For each x value, there is only one y value. And then for function notation, instead of a y equals, like we had here, we'll have an f of x. And it represents the value of the function at that specific value of x. So notice we have the same function listed again. And what we're saying here is x is the input and f of x is the output for each individual x value. Okay, so now we're going to look at an example. So let's say we're given our function. Look at our steps over here, and we want to find f of 30. So that means we want to evaluate our function at the x value of 30. So we're going to replace all the x's with 30 and simplify. Okay, so for some students, it may be easier for them to look at our function without the x's, and then we insert what we were replacing x with. Now, because we're working with some gross decimals here, I would suggest that you use a calculator and type it in exactly like you see. Hopefully you get 14.1. Okay, so now I want you to take us a minute or two and try the example you try. Hopefully you found your answer for that example you try to be our function evaluated at 2 equals 15. Let's look at some more examples. Okay, so notice we're going to evaluate each function. The first example, we're going to find h of -x. So to evaluate h of -x, we are going to take our original x, or each function, and take out the x. Notice the -3 is not under the radical. And we are going to replace this x with the -x and then simplify. In this case, you can't really simplify a whole lot. And so guess what? You stop the end. In the next example, notice we're going to look at the j function. Right, we're going to look at the j function. So I'm going to write my j function without the x's. And this time, we will replace the x's with an x minus 5. Now this is where you will have to do some algebra. So remember, the quantity squared means we're going to write the x minus 5 twice. I can distribute the -10 to both terms, so minus 10x plus 50, and then the -3 is alone. When you distribute x minus 5 times x minus 5, make sure you multiply the first, then the outers, then the inners, and then the last, and then you combine like terms. It should give you x squared minus 10x plus 25, and then we can combine the rest of the terms. We know 50 minus 3 is 47, and then all that's left for us to do is to finish combining the like terms. So notice we'll have an x squared, -10 and -10 is -20x, 25 plus 47 is 72. And guess what? That's it, you're done. Let's look at the next example. So notice this time we're looking at the k function. So I'm going to take my k function and I'm going to copy it. And I'm going to take the x out and write the rest of the function. Now notice this time we want to find of x plus 1. So x plus 1 will go into those parentheses. And now we're just going to simplify. So we'll have 3 over, we'll write the x plus 1 twice. And remember, we are going to distribute. So I want to do the first multiply, the outers multiply, the inner, and then the last. Okay, so 3 over x squared plus 2x plus 1 minus 16. All that's left for us to do is to combine like terms in the denominator, which you can only add the 1 and the negative 16. So 3 over x squared plus 2x minus 15. And guess what? You're done. The end. Now take a minute or two and try those 3 example U-tries. Okay, so hopefully that you found for n of negative 2x to be the 4x squared minus 4x plus 3. For p of x plus 3, hopefully you found to be the square root of 22 minus x minus 6, and the function m of x minus 6 to be 4x minus 19. And now you can do the first part of the assignment, the end.